Hey guys, so in this video, I'm going to do AMC 10B 2021 spring number 18. So this problem says a fair six-sided die is repeatedly rolled until an odd number appears. What is the probability that every even number appears at least once before the first occurrence of an odd number? Okay, so I wanted to make sure that I did this problem in like my own way. I didn't want to just look and see like again, I'm sure there's like some easy trick, especially when it comes to probability. Some people just have a very intuitive mind for probability. For me, I don't really think of like the shortcuts. I just kind of have to do it out in whatever way I can. So I'll just kind of show you guys how I thought of it. So the idea is that we're going to keep rolling this die, and we want it to be that we roll every even number before we roll any odd numbers, right? So the way that I kind of thought about this was, well, first of all, the order in which these evens appear can happen in any of 3 factorial different ways, right? Because we have 2, 4, 6. So maybe we'll see our first number will be a 2, and then our next we'll see a 4, and then next we'll see a 6. But it could just as easily be 4, 6, 2, or 4, 2, 6, or dot, right? So there's 6 ways for that to occur, right? So that's like our first piece. So obviously we need some even to show up first, and that will happen with a chance of 1 out of 6. But the thing is, let's say our first number is a 2, right? Well, we could have any number of 2s before we would roll our next even, maybe a 4, right? So we can either have 1 2 or 2 2s or 3 2s or 4 2s or et cetera, right? Which, if we think about it, this will happen with chance 1 out of 6, and this will happen with chance 1 out of 6 times 1 out of 6, and this 1 out of 6 times 1 out of 6 times, right? Dot. So if you think about it, the chances of seeing any of these numbers of 2s would be basically this geometric series, right? And for those of you who know how to find the sum of a geometric series, it's the first term divided by 1 minus the ratio. So in this case, the first term is 1 out of 6, and the common ratio is also 1 out of 6. So it's 1 out of 6 minus 1 out of 6, right? For these are the probabilities of us seeing any number of 2s in a row. It could even technically be an infinite number of 2s, but obviously we're hoping that that's not the case. So I'm going to kind of try to put this together. So far we have 3 factorial times 1 out of 6 over 1 minus 1 out of 6, right? Now, then we want to roll our next even, which could happen, or let's just say it's a 4, for example, right? Like, let's say our next even is going to be a 4. Well, that's going to happen with chance 1 out of 6, right? Now, our next several rolls can either, so assuming that our first 2 rolls were a 2 and a 4, without loss of generality, right? Then our next several rolls can be 2s or 4s, right? And that happens with chance 1 out of 3. And so we're going to say like our next roll will, let's say, be a 4, right? These were all 2s, and then we got a 4. So our next roll could be not a 4, like it could be a 6, or it could be 4 and then a 6, or it could be 4 2 4 and then a 6, right? So there's many different cases that can happen, and the probability of seeing either a 2 or a 4 is 1 out of 3, right? But keep in mind that like we might not see any 2 or 4 in the next roll, right? So our probability would be 1 over 1 minus 1 out of 3, right? Because there's the possibility that like we don't see any 2s or 4s after that first 4. Maybe we just go straight to the 6, and then the probability to roll the 6 would be 1 out of 6, right? So if we multiply this together, we get 3 factorial. So here I'm going to erase this, right? So we'll have 3 factorial times 1 out of 6 over 5 over 6, which is 1 out of 5, times 1 out of 6, times 1 over 2/3, which is 3/2, times 1 out of 6. 3 factorial is 6, so those will cancel. 3 cancels with 6, leaving a 2. We're left with 1 over 5 times 2 times 2, or 1 over 20. So our probability is C, 1 out of 20. And again, I'm sure that there's much easier tricks to solve the problem, but I I don't want to just steal somebody else's solution and call it my own. So I'm always trying to find my own way, even if it may not necessarily be the most efficient way to solve the problem. But all right, so that's how I did number 18. And that'll be that. All right, I'll see you in my next video. So my next video will either be 19 and 20 or just 19. I'm not sure yet, but I'll see you there.